Okay, we're gonna work on question number 7. Question number 7 gives us a graph of potential energy versus position. They also give us the mass, it's equal to 2 kilograms. And then these are formulas that we're gonna use through the problem, so it's just for us to remember. Okay, number A is asking when is the force acting on the object equal to 0. So we know that the derivative of the force gives us the slope. So we can notice that at 4 the slope is equal to 0, at 7 it's equal to 0, and at 9 is equal to 0.
For part B, it wants to know the direction of the force acting on the object at x equals 2, 4, 6, 8, and 10 meters. So given the equation that the potential energy equals the negative integral of force, you get, for the first part of the graph, since the graph is potential energy, you want to take the derivative, and since the slope is negative, that gives us a positive force at x equals 2. At x equals 4, the slope is 0, so the force is 0. At x equals 6, the slope is positive, so the force is negative. At x equals 8, the slope is negative, so the force is positive. And at x equals 10, the slope is positive, so the force is negative.
For part C, it's asking if the forces acting on the object is stronger at x equals 1 meter or x equals 2 meters. So using the same equation that potential energy equals the negative integral of force, we can look at where the slope is greatest, and that's at x equals 2 meters.
For part D, the question says the object is initially held at rest at x equals 1 meters and then released from rest. And it asks what the velocity of the object is at x equals 7. So we would use the energy conservation equation, where initial potential energy plus the initial kinetic energy is equal to the final potential energy plus the final kinetic energy. So for D, we know that at x equals 1, the initial potential energy is 300, and since the object is held at rest and the velocity would be 0 there, the initial kinetic energy is 0 also. At x equals 7, the final potential energy is 200, and the final kinetic energy is 1/2 times 2 times the force squared. So using the energy conservation equation, we put the initial potential and the initial kinetic energies on one side, 300 plus 0, and then we put the final potential energy plus the final kinetic energy on the other side. So we have 300 equals 200 plus 1/2 times 2 times v squared. Then we solve for v squared and multiply and move over to the other side, and we get v squared equals 100. And then once we solve for v, we get that v equals 10 meters per second squared. Part E says that the object is initially held at rest at x equals 8 meters and then released from rest. And then it asks what the maximum value of x that the object reaches and what the minimum value of x that the object reaches is. So at x equals 8, the potential energy is about 100 joules of energy. So, and at about x equals 9, when the slope is 0, it is the amount of joules of potential energy is 50. So it lost 50 joules of potential energy, and it went into kinetic energy. So the kinetic energy would then go back into potential energy, going back up 50 joules of energy, which would be at x equals 10 when the joules of energy is also at 100, and the potential energy is also at 100 joules of energy. And then the minimum place that the object would be is at x equals 8 meters, because the object would only be moving forward because the potential energy, it wouldn't have any force moving it backwards. So that's the only place where it's at rest and where it starts, is at x equals 8.
For part F, it tells us that the object begins at x equals 1 meters, has a velocity of 5 meters per second, and ends at x equals 6 meters. So and wants to know the energy lost due to friction. So the potential energy at x equals 1 meter is 300 joules, and the kinetic energy is 25, and the final potential energy is 150 joules. So we have our equation 300 joules plus 25 joules equals 150 joules plus the energy lost due to friction. And then you solve and you get 325 joules equals 150 joules plus the energy lost due to friction. So you get the total energy loss is 175 joules.